All right, here is our next lesson. It's on equations of circles. This is section 10.6 in your book, and we're going to go through this once again. A great opportunity for you to slow it down, take it as you need it, and go ahead and pause it whenever you feel necessary. If I'm writing too quickly for you, just pause it. Do it stepwise, okay? Equations of circles. You can write the coordinates of a circle if you know the radius is the first thing we need to know. And we've discussed radius before because radius tells us how far is each point on the circle from the center. And that leads us to our second thing that we need to know. We need to know the center. Because if we know the center, we can write an equation for this circle. Now this diagram in the bottom right hand corner, I'm going to go ahead and mark the middle just so you can kind of see what I'm talking about here. I've got the center, and when I have that, I can run a line from the center to the outside, and I'm going to go ahead and do it in yellow because I've already denoted the radius in yellow, and I can label that R for radius, okay? And also that middle point is going to be HK. We're just giving it definite points. We're saying whatever it happens to be, the middle is H comma K. Okay? And this point where it intersects the outside is going to be just some point XY, XY. Okay? That's going to be important in a second when we start to write the equation for a circle. So we're going to denote the center with H comma K, which is an X and a Y wherever that center happens to be, and XY is going to be the point on the outside where that radius intersects. To find the equation for the middle of the circle, we're going to need to find the radius first. So let's recall the distance formula. For those of you out there who are trying to recall the distance formula, it is square root, big square root because we've got a lot inside of it, x minus h squared plus y minus k squared is equal to r. Remembering that the distance between 2 points, any 2 points, is x1 minus, or x2 minus x1 squared plus y2 minus y1 squared. Okay? But in this case, we're putting in x and h. So we're using our points. We are using our points. The center, which we will recall. We've got center and a point on the outside. The radius is joining them. Okay, so we've got the radius here joining them. Interesting. We have our radius, and remember this center we are denoting H comma K. H comma K. This outside point is X comma Y. Alright? And so our radius gives us this distance formula gives us our radius. It tells us how long our radius is. And this is good for us because we don't want to know just one of these points, x, y. We don't want to know just one of the points on the outside of the circle. We want to know them all. And that's why we leave it general. And so in order to find the standard equation for a circle, here's the big finale of this slide. The standard equation for a circle looks like this. We're going to square both sides of this distance formula. So we're going to have x minus h squared plus y minus k squared is equal to radius squared. Okay, so we square both sides of this distance formula, telling us that we have all of the points around the outside because h and k are the center and x and y are some point on the outside of the circle. So it could stand for any of the points on the outside of the circle. Okay, so What you're taking away from this slide is right here. Boom. Okay? Standard equation for a circle. Now, we're going to move on to example 1. In example 1, we are going to write the standard equation of a circle. They are giving us the center. They are giving us the radius. So what I'm going to do right away, right off the bat, is I'm going to say this is h. This is k. All right? So when I label those h and k, I'm going to write the standard equation for a circle. It's x minus h squared plus y minus k squared equals r squared. Now, it's a plug and chug kind of a game. All right? So I've got x minus a negative 4 squared plus y minus 0 squared is equal to, undo there, y minus 0 squared is equal to, now my radius is a decimal. That's okay. It's allowed to be a decimal. And so when I denote my radius, I'm just going to say it's 7.1 squared. Okay? Now let's simplify this. When I come down, I know that x minus negative 4 is going to be x plus 4 squared plus y minus 0 squared is equal to, and you can go ahead and square this radius. That's okay. And that's going to be 50.41. That's the standard equation for the circle. And so if they give us the standard equation, we can go ahead and find the radius later by taking the square root. But not right now, we're not doing that. This is the standard equation. You could put this, solve this for y, put it into your calculator, you'd have the standard equation for a circle. Also, you could also put it into your calculator. It would give you something that graphs a circle. These are good things for us. You can also just graph it, which we're going to do in a couple minutes, by using what we know about this equation with the center and the radius. All right? Here's another example. This is example 1.5. This is one for you to do. So I would urge you, go ahead, pause this for a couple minutes. Write this example down. Try it on your own. I'm going to go through it right after the break. So go ahead and pause right now if you're going to do this one on your own. Okay, so we're back from the break. Or maybe you're not. Maybe you didn't break. But if you didn't, that's okay. If you think you got it, test yourself as we go along. Test yourself along with what I do. So I'm going to label this H and K. And here's what we're going to do. We're going to go ahead, and a good strategy for you is just write out the standard equation for a circle. So x minus h squared plus y minus k squared is equal to radius squared. So then when I go back and I fill in what I know, I've got h is minus 5. So I've got x minus a negative 5 squared plus y minus 0 squared is equal to radius squared, which is 4.8 squared. Okay? And so when I do this, I bring it down. I've got x plus 5 squared, because when I subtract a negative, I get a positive, plus y minus 0 squared is equal to, and when I square 4.8, I get 23.04. Okay? That's the standard equation. This is our answer. So we've written the standard equation for a circle. All right? Once again, feel free. Rewind. See that again. If you didn't get it, try it over. The next part. They might give us the center and the radius, or they might say, you need to find the radius. And so when we need to find the radius, we are going to have to use the distance formula given what we know. We know that this point and the center are related in that the distance between them is the radius. And so if the distance between those two things is the radius, if we use the distance formula, and we are in recollection mode right now, x2 minus x1 squared plus y2 minus y1 squared. So we're going to plug and chug. Does it matter which one you do first? No. Because the distance between them is the same, whether you go from point A to point B or from point B to point A. So I'm going to pick something easy for myself. I'm going to say that this is going to be square root 5 minus 1 squared plus. So I did 5 minus 1, and then I'm going to have to do negative 1 minus 2 squared. All right, let's simplify. 5 minus 1 squared would be 4 squared plus, and this would be negative 3, so this would be negative 3 squared. So this is going to be equal to 25, because I'll have 16 plus 9, so 25. And I know that the square root of 25 is 5. You lucked out. They gave you a nice and simple one. They tossed you a meatball on that one. Okay? So now I've got distance. Well, this is really equal to radius, right? Because that's the distance between a point on the outside and the center. That's the radius. So now I can just simply fill in my equation knowing what I know. So I've got x minus h squared plus y minus k squared is equal to r squared. Let's fill it in. X minus 5 squared plus y minus 1 squared is equal to 25. Started writing on the white there. That's all right. X minus 5 squared plus y plus 1 squared is equal to 25. You see how this works? We had to find the distance between the point on the outside and the center. That's our radius. Our radius was 5. And so when we find the radius of 5, we can plug it into our equation. This is our answer. Yes, it's a little bit of work to get there, but we're using the same formula over and over. This is standard equation for a circle. Now it's your turn. Go ahead and try this one. If you want to pause it right here, that'd be great, because you can try this example on your own. Write it down. Use the previous example that you took notes on to do this example. This is a great opportunity for you to slow it down. Okay, so go ahead and pause it here, and after the break, I will show you how to do this one. Okay, so you're probably back from the break now, if you decided to take the break. And once again, there's no shame in taking a break. There's no shame in going and getting a drink of water. That's okay. That's the point of this. That's the beauty of this situation. And so now we need to find the distance again, just like we did in the last example. x2 minus x1 squared plus y2 minus y1 squared. Okay, all that's under the square root. So when I plug this in, I'm going to go this way. 4 minus 2 squared plus, then I'm going to have negative 3 minus 1 squared. Here we go. It's exciting times. We've got 2 squared plus negative 4 squared is equal to. Now here we go. We're going to have 4 plus 16. Some of you are going, but 20 is not a perfect square. How are we going to do that? Watch how this works when we put it into the equation. Now, standard equation for a circle. X minus h squared plus y minus k squared is equal to r squared. Watch how this works. X minus, and now this is h and this is k. Remember, 4 goes here plus y minus a negative 3 is equal to square root of 20 squared. Watch how this works. X minus 4 squared plus, now this is y plus 3 squared. When I square a square root, so for example, if I take the square root of 9, that would be 3. Then I square that, I would get 9. But in this case, I'm squaring the square root, so you don't need to take this to decimal form before you do it. The square root of anything squared is that number. This is the standard equation for my circle, right there. Okay? Now, next 2 examples. We're going to be doing a little bit of graphing. Hold on to your hats. Given that we have the equation now, we're going to go the other way. We are going to find the center. We are going to find the radius. Well, if I look at this, I know that the circle equation is x minus h squared plus y minus k squared is equal to r squared. So when I look at my equation, I'm subtracting h. So this is h. But x plus 2 is really x minus a minus 2. And so my center coordinate for my h is minus 2. What am I subtracting in here? I'm subtracting k. I'm subtracting 3. So my center coordinate is 3. Do you see how I did that? The tricky part is if they're adding, they must have subtracted a negative, so it has to be a negative. And my radius, this is my radius squared. So 9 is equal to radius squared. So I'm going to take the square root of both sides. So the radius is 3. This is my answer right here. Okay? When I have this, I'm not crossing that out. Don't worry. Let's try that again. My center is negative 2, 3. My radius is 3. Minor technical difficulties here. No worries. I'm not worried. We're just rolling through it. Here we go. Center is negative 2, 3. Radius is 3. Now, when I go to graph this, this is what it looks like. I know that my radius is a standard thing. The radius is 3 all the way around. So if I go to my center, I'm going to say, okay, I'm going to count by 2's on this. Okay? I'm counting by 2's here. I'm going to make my center red. When I go to my center, I go to negative 2, 3. Okay? That's my center. My radius is 3. Watch how I do this. When I go ahead and I say, I am going to draw this circle, but the radius is 3. So what I'm going to do is this. I'm going to go 3 up from here. Remember, I'm counting by 2's. I'm going to go 3 out from here. I'm going to go 3 down. I'm going to go 3 out to the side. Now, I have something that looks like a little bit of a modified cross. This is where your artistic abilities take over. I'm going to go ahead and connect the dots here. Look at that. That's my circle right there. And so I can find points of intersection. I can say, where does it cross the x-axis? Where does it cross the y-axis? Things like that. So you've just drawn a circle by using the center and the radius. Now here's an example for you to do. Notice it says your turn up here. That means you can go ahead and pause. You can go ahead and look at that last example that we did. Go ahead, take your time on this one. Write down the example. Do what you need to do in order to make this happen. If you just want to watch, go ahead and just watch. So go ahead and take a pause now if you need it. Maybe you're back from the pause. Here we go. What am I subtracting from x? I'm subtracting 3. So that must be my h. So my h is 3. What am I subtracting from y? That's my h. But remember, I'm subtracting a negative 1. And so this must be negative 1. My radius squared is equal to 4. So my radius must be equal to 2. Do I need to count by 2's this time? No, I don't. That's the beauty of graphing. You can count by whatever units you want. Now, when I'm graphing this, I'm going to graph in red once again. Then we're going to let our artistic abilities take over. So 3, negative 1. I go out 3, I go down 1. There's my center. My radius is 2, so I'm going to go 2 from each of these points. I go over 2. I go this way 2. I go up 2. I go down 2. Notice I have my cross shape. Artistic abilities take over right here. Don't worry. This will come with practice. If you don't have graph paper at your house, you can just draw this on your paper, but make sure that I see that you're using these correct units to go out 2 from each side. Okay? That was graphing circles. Not really that bad. Feel free. Watch it again. And when you come in tomorrow, let me know that I said you need to use your artistic abilities to take over the end part of that circle drawing, because that's going to be my key to know that you watched the lesson all the way through. Okay? So let me know you used your artistic abilities. Show me the circles that you drew. I hope you enjoyed the lesson. We will